Okay, so I'm going to just review a little bit. Oops. Excuse me. I'm just going to review a little bit about molar mass and conversion factors. So we're going to do a little bit of review. When this question asks for the 3.04 moles of nitrogen as you're given, and it's asking for the mass. So what we start with, like what I taught you guys before, is we're going to put the given out in front, which is 3.04 moles, and this is of nitrogen, which means in order to get that to cancel out, we have to set up conversion factor with 1 mole on the bottom. So 1 mole of nitrogen. Now, what is equivalent to 1 mole of nitrogen? The weight of 1 mole of nitrogen, which is the 14.01 grams. Then, moles cancel and you're left in grams. When you do the calculation for that, you end up getting 42.5904 grams. The sig figs on this are 3. You have 3 sig figs here and 4 here, so yes, values from the periodic table count, which means that my answer rounds to 42.6 grams. So that is the answer for the first one. Now, that is the type of stuff that we did back in Chapter 3, but that's just a little refresher for you. Now we're going to do a new application of that, where instead of just using something simple like nitrogen, we're going to have to calculate the molar mass of ammonia instead of just nitrogen, so that we can plug in the molar mass of ammonia somewhere like right here. Okay, so this is a similar type of problem. I'm going to do this one right here. What is the mass of 3.04 moles of ammonia this time? Same type of conversion factor. We got 1 mole of ammonia. What is equal to that? Well, you've seen me calculate the molar mass of ammonia and the atomic mass of ammonia. Remember, it's the 14, like what you see here, plus the weight of 3 hydrogens. Remember, ammonia is NH3. So we add 3 more to it, and then you have the molar mass of ammonia. Moles cancel, left in grams. So the answer for this one, raw answer, was 51.68 grams. But we got 3 sig figs here and 3 here, which means our answer has to be 3 sig figs, so we round it to 51.7 grams. So that's the answer for that one. The next one says if you have 0.257 moles of, in this one, calcium nitrate. You got to be able to figure out how to do this. So you have calcium, which is a 2+. Nitrogen is a 1-, which means I need 2 of them. So we got to get the molar mass of that whole thing. So before I even start this problem, which I guess I could set it up like this, knowing that I need 1 mole of calcium nitrate. Before I can figure out this top part, I have a little bit of other stuff to do. So I've got sodium, and I have 2 of them. Oops, sorry, calcium, pardon me. And I only have 1 of them. Okay, calcium weighs, and remember I grab all these off the periodic table. Nitrogen, I have, remember, if you look here, I've got double this amount, which means I have 2 nitrogen, and I have 6 oxygen that I have to count in for the weight. So 2 nitrogen, 2 times 14.01 grams, which gives you 28.2 grams. And oxygen, I've got 6 of them at 16.00 grams. It gives me 96.00 grams. When I add all these up, I get a molar mass of 164.1 grams. So that is the weight of 1 mole of calcium nitrate, 164.1 grams. When I do the math, moles cancel, I'm left in grams, and then I get, I'm just going to erase some of this to clear some space for myself. But I get 42.1737. But remember, with sig figs, I only have 3 sig figs here, 4 here, so my answer is 42.2 grams.